Just closing.
And yeah, so I guess we should just say welcome to the Cloud Native New York meetup. We're thrilled to have Jim Slavin here from Agile Cloud Institute to talk about architecting the Agile enterprise with an Agile Cloud Manager and present the work that he's been doing there. Jim, as a start, we'd love to hear more about your background and who you are, and then of course the stage is all yours to talk about this topic. Welcome you.
Nice to meet you. We had one nice conversation over Zoom before. I have more than 20 years experience. I've been doing enterprise architecture in different capacities for most of my career. Grew up doing programming just because I grew up in Silicon Valley, and you just sort of do that kind of thing when you're a kid. And I just was always interested in business modeling and the interface between business modeling and marketing, customer-centered business development, and architecture and programming are my spaces that I'm interested in. And so over time, if it's okay, I could share my screen. Here, over time, this has evolved into, let's see, screen. I can share the whole, I can share the whole screen. Over time, this has evolved into, just going to close a couple more things here while we're talking. Over time, this has evolved into an app that is something that we work with different people on. And let me get more specific, and if it's seeming slightly vague, it's because I was waiting to share my screen until I had opened this. Here we go. We'll go and show you this. There's a tool here that has evolved over time, and it's a lot of consulting that's been done over the years, and a lot of listening to people and seeing problems. And it's available through this website. And more specifically, I'm trying to take you to the demos and show you how to find the demos. And the demos are right here. And I'm going to right click on them to open. And if you're logged in as me, then you see this. But if you're not, you clone this. There's some instructions. But more specifically, there are GitHub actions in here. And while we're going through what this is all about, I will just let these run in the background. And the idea here is that we're just going to start all of these one at a time. There are 8 demos. And they run on 2 different operating systems. So there's 4 demos that run separately on each of 2 operating systems. And I'm just starting these demos for you so that you can see them. And I'm not sure if you worked with GitHub before. This works actually in any pipeline tool. So the tool can run inside your Azure DevOps. It can run inside Jenkins. It can run inside Bamboo, or if you're using GitLab. But the idea is that we want to make it really simple for people to start. So we've got this example of it running in GitHub, and then we've got another way of running it in your local dev box. But we've got a cross-functional group of people here. For example, Mike, you mentioned you're a program manager, and this demo in particular is meant to be point and click. So the intention of this is to show that we've got all these different bits of infrastructure. Basically, we're creating things like virtual private clouds and resource groups that have things like auto scaling groups in them that create infrastructure, and then it destroys them, and it does it in an automated way. We're just going to count. We got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you see 8 demos running, and we can forget about these while we're going through the conversation here. But the idea is we just want to start realizing on a point and click basis. We started the creation of 8 different appliances, and then they'll be destroyed. And that takes us, while that's happening, to an ability to talk about some things. And here I will show you a problem definition. And Mike, you mentioned legacy systems you're starting with. The core of this, when I think about Agile, I think about how does the customer adapt to, how does the company adapt to customer change? So the customer is changing all the time. They're trying to do whatever they're doing in their life, and they need to make changes. And so they're reaching out to vendors like the company we're engaged with, and the company needs to make changes on an ongoing basis. And it's hard to do that when we're in the environment most companies are in, which is every product group in most companies has redundant engineering costs that can grow to be very expensive. And that manifests in terms of redundant definitions of storage. For example, every product group will define storage its own way, even though they're really ultimately doing the same thing. Redundant definitions of databases that ultimately are very similar to each other in terms of the database clusters and all of those types of rules. And redundant definitions of pipeline logic to do things like deploy storage or deploy databases and deploy messaging systems and the other aspects of an architecture. And that boils down to redundant projects and a ton of extra work that's being done by engineering groups, by IT groups, that doesn't need to be done that inefficiently. So the implications of that are that a company will lose revenue due to unaddressed use cases because they don't have the resources to run the development of all the different use cases they could. Systems are often not adequately integrated because there's so much extra overhead trying to do all these redundant implementations, and there can be a diminished customer experience. For example, I'm not sure how it works in your organization, Mike, but I've been told in different financial institutions that oftentimes the big problem is that it's very difficult to get people to sign up for multiple products. The organization becomes much more profitable if any given customer has 2 or 3 or 4 different products that they have instead of just one. But the onboarding process, oftentimes in the financial institution, can require every customer to provide the same exact detailed information every single time they want to sign up for a new product. And that's because the systems are not integrated with each other. So the company can make a lot more money if the systems are integrated with each other, but it's hard to come up with the money to do that because the money is being spent defining storage, the same type of storage in 10 different places across the enterprise, or the same database in 10 different places across the enterprise or more. So the idea of this tool is to have a specific benefits in terms of making the templates reusable. So there are fewer templates that involve less pipeline code, and it's reusable. And there's reduced operation cost due to easier deployments and maintenance. And that can also manifest in terms of reduced cloud provider costs. If, for example, you use the tool like this to roll over systems from one cloud to another, to fail them over to one cloud and fail back, if you have the ability to do that, you're in a stronger negotiating position with the cloud provider. And before we get into the other 5 slides and what this is, this slide just says the problem definition and how we get to the implications and the benefits. Does anyone have any comments or questions at this level?
I'm good.
Okay. I'm a fan of connecting people to the way things work. And this particular slide has numbers on it so that we can guide through the different things here. Number 1, I'm going to tap on. I think everything starts with a customer. And this helps me when I look at it and I try to talk with people about enterprise architecture from a cross-functional standpoint and from the standpoint of how do we as an enterprise try to be more agile and more customer focused. If I start with 1, everything's about serving the customer. And we as an organization over on 2 here, which I'm going to tap, are a collection of people, but the people are trying to interface with each other and with the customer through what we have here at 3, which is all these enterprise systems. And in a particular company, you might have lots and lots of systems, but they might get bundled into 8 different buckets. And I've laid out here the 8 major buckets in an enterprise architecture. And you've got sales, you've got the website, you've got support, you've got marketing, you've got finance, you've got human resources, and you've got this big bucket operations, which is the general fulfillment of value for the customer. It's different in every industry, but you've got operations, and they all need to interact with each other through an integration layer. And the problem you get here, it's kind of summarized over on 4, is that in most companies, these are defined in terms of stacks, and the stacks can become very brittle because, as we were putting out in the last slide, pipeline code can be redundant. System definitions are usually redundant, and it usually takes way too much engineering to do things than it could take. And the idea, and I'll show you in some detail about how we go about addressing that problem, but if we move to 5 and just go through some concepts here, this particular tool, it's a free tool to use, free to use tool. It reorganizes stacks inside something that we're calling appliances, portable appliances, that can become as easy to use as a toaster. A toaster might be very complex if you try to make your own, because you got to figure out how to plug it into a wall and collect the energy from the wall and translate the energy from the wall into the heating element inside the toaster. You got to be able to turn it on and off. You know, you got to have a spring mechanism that turns the heating on and off, and that pushes the toast up. You got to have a heat controller that lets it be hotter or colder. So there's all these different complex things in a toaster, but from the standpoint of a user of a toaster, all you have to do is plug it in the wall and put the heat in the middle setting that's supposed to be normal, and put a couple pieces of toast in and push down the the button that you push down, and wait however many minutes, and the toast pops up. And the idea is we're trying to make it that simple, and it's easier to do that because we've reduced all the redundancy that's present in most companies. And that's the core concept behind this. So that enables a company, if we move to 6, to become a lot more agile, because evolution is easier, because operating on the systems becomes a lot easier. And the next slides get into, at a high level, some of the more technical or architectural things. They're designed to be cross-functional, but they're not super high level like this. Does anyone have any comments or questions while we're still at the business level and seeing that people are interfacing through all these different buckets of systems? Okay.
I'm good.
We've got, go ahead, Mike. Or who said that?
No, I'm good. Just
Okay.
keep going.
Here we have what the Agile Cloud Manager actually does and how it fits into the beginning and end of its beginning points and its end points. So every company is going to use pipelines on one level or another to deliver its systems. So the starting point here is you can use any pipeline tool that you're already using Jenkins, using Azure DevOps, using GitHub, GitLab, Bamboo, it doesn't matter. What the Agile Cloud Manager is, it's a program that can be installed in an agent. A pipeline basically has agents, and the agent, when it's provisioning itself, provisions itself with the Agile Cloud Manager. And that's what we start to see on 2 here, where what the Agile Cloud Manager does for the pipeline is it exposes a command line interface, which is a collection of about 5 or 6 commands, each of which has an on version and an off version. And what those so they're all in one line. So the fact that they're on one line means the pipeline code can become a lot simpler. And what the command line interface commands do is they interface with these automation algorithms that do a lot of the things that pipeline code currently does. But what happens is you don't need to keep rewriting your own pipeline code because you can use these automation algorithms and just hit them up with command line interface commands. And what the algorithms do is they reach up several places. The first is up here on 2B, where you've got what we have is called a domain-specific language. And the domain-specific language has essentially appliance templates and system configuration templates. And we'll get in the next slide into what these things are. But essentially, it's a very simple way of laying out a very simple and structured way of mapping a bunch of variables into the templates you already have, and then orchestrating the templates you already have, which takes you to 2C. Everybody's already using some way of getting their systems up into the cloud. Oftentimes people use Terraform, or they'll use CloudFormation, or they'll use Packer, or ARM templates, or they've got other types of templating tools, other types of tools. And these things generally orchestrate deeper level things like Ansible playbooks, or chef cookbooks, or scripts in different scripting languages like PowerShell or Bash. And then we've got built-in controllers that come with this app for the things that are being pointed to. And there are also custom controllers where you're able to put your own logic into a template that we've got for a custom controller. And then that enables you to basically run any other kind of tool. And that ends up enabling you to send out a resulting cloud appliance. And that's what we're doing with this demo that I stripped up at the start of this. The demo's running 8 different algorithms, 8 different sets of algorithms that are spinning up an appliance and then tearing down an appliance, each one of them is. And this is the heart and soul at a beginning and end point level of what the program is doing picture. And the next slide takes us into how this relates back to the enterprise level I was showing you before. But while we're looking at this, does anyone have any questions about or comments about the different pieces of this, how the things you're doing over in 2C are orchestrated through the pipeline from using the command line interface and the domain specific language? Okay. So this is that piece is the technical level of what this little program does. And here, what we see in this slide is on the top in number 1, an enterprise view. And I showed you before, 2 slides ago, some human beings trying to relate with each other through this place that gets all stuck in number 1 with sales and website, mobile apps, support appliances, marketing, finance, human resources, ops, all trying to integrate with each other through an integration layer. And that's the enterprise level of this. But inside each one of these buckets here that we're showing how to turn into an appliance, you have the things that are on in the lower level here in this appliance view. And that starts here with 2. We'll have a very simple appliance template, which I can show you later. Might be 3 or 4 or 5 lines. They're very, very simple. They're designed to basically tell you which of the system templates to use, where to get the template, and what order to run them in. And it's really not any more complicated than that. And each one of these appliance templates is going to refer to several different any one between 1 and 5 or 10 or 3 or 8 or however many system templates you might have. And the idea is in your company, you might have templates for storage, you might have templates for databases, for messaging systems, for microservices, for front-end apps, or other things. And this level 3 here that I'm showing you, I'm kind of highlighting 3 in the middle. That's where you get the tremendous benefit in terms of savings and efficiency in your engineering organization. Because, for example, if we think just at the lowest level of storage here, in many companies, the same exact definitions of storage, like file storage or blob storage, are going to be defined in the same way redundantly in many different parts of the company. And what this tool makes it very easy to do is have a central repository inside your enterprise where every different type of every different system can be defined as a template, and then the groups can subscribe to whatever subset of these system definitions they need. And that means from a project management organization standpoint and from an enterprise architecture standpoint, you can look at all these components of your systems, figure out what's reusable, what can be reusable, and then shrink out all the waste in the organization by having, for example, for blob storage, one definition of blob storage. For your work group file systems, you can have one definition of work group file systems. For your large transaction website, storage that has, tiered storage with, file systems and SSD and blob storage for longer term stuff and tiering and all of those types of things. You can define that in one place and have the template be parameterized so that it behaves differently when different parameters go into it. So all your different work groups can have a storage system that behaves differently for them in a customized way, but it's using the same template. So if you have 10, for example, implementations of the same type of storage system, you can shrink that down to one implementation, and you can make that one implementation parameterized. It might not cost you 10% of what you were spending before, because making it parameterized takes a little bit more engineering work, but it might cost twice as much, and twice as much of 10% might be 20%. So in some cases, you might literally save 80% of your engineering costs for a particular system by reducing 10 implementations down to one that's parameterized. And from a security standpoint, this enables the enterprise to focus on hardening the security of a much smaller number of templates, and that enables the enterprise attack surface to be shrunk. And what these tools do, if we look at them, these system templates do, is they work with the third-party basic building blocks, and these are basically the things that you already have in your company. You've already got Terraform modules, you've already got CloudFormation templates or ARM templates, or whatever else you're using, Packer templates. And so we're taking what someone already has in terms of their existing templates, and we're taking the pipeline tool that they already have, and we're creating this meta layer in between that enables these vastly diverse systems with huge amounts of redundancy in them to become streamlined and reused and more efficient without requiring a company to change the tools it's using. And when we look at this, I mentioned before a domain-specific language. That's what we're calling a DSL here. That's referring to these levels of templates, the system templates and the appliance templates. And when I mentioned a command line interface, for non-technical people, that's the CLI here. And they're basically enabling the company to operate on its appliances. And this is just another way of reframing what the prior slides were showing of this enterprise view, and then a little bit more deeper technical view. This is more thematic and linking those together. The next couple slides, the last two slides are, one of them is about the domain-specific language that you're seeing at levels 2 and 3 here, and one of them is about the command line interface. But do people have any comments or questions about all of this?
I'd like to ask something. So the idea over here is from the template, like the number 3, the layer number 3, is to collect from a storage perspective database, like for each category, which are the definition, like what does it look like, the storage that it's used in every group, and create templates so that you can provide, let's say, a library of this template that then you can vet, like, okay, this is how we are going to do this thing, and reducing so the number of what you are, what each team is using, but providing something that can, I can instantiate this template and I can still offer you exactly what you need at this point. Correct?
Yes. Yes, and from an organizational velocity standpoint, if we're people who are trying to be as agile as we can, it's just a lot easier to focus all our energy on one project than on 10. So if there's a change, it's just a lot easier to migrate in something that's a change than it is to it's a lot easier to do it in one place that's reused everywhere than it is to do it in in 10 different projects separately.
Okay, and the number 2, so the appliance template,
Okay.
that refers more specifically to like virtual machine, correct?
I can show you, and
Okay.
let's just bounce back. You see these things are still running. I'm still figuring out the Zoom interface here. So for me, I need to move this around just a little bit in order to get the ability here. This is what I'm looking for. Here, let me tap on this. No, let me tap on this. An appliance template is going to look like oh, I know where I'll find that for you. There's the engineering page and the architecture page, and the engineering page also points to this in the architecture page. There's a low-level design document, and this has some of the same things in it, but here is an example of the structure of an appliance, where if I just raise this up just a little bit, you might have in it a few lines, and each line is basically saying that it's going to access a particular template that's a system template. So in the top, it's telling us what we're looking at. We're looking at a system name, and then we're looking at the repository where the system comes from, and then we're looking at the name of the template. But down in the image, you're able to see that we've got an example here for a particular appliance. It might start with storage at the low level and then put database just above that. It might have some microservices just above that, and there might be a user interface just above that. And it's pointing out that each one of these is in a particular template that it's getting from a particular place. And that's as hard as an appliance is supposed to be. And it's supposed to be operated on by these command line interface commands. I could show you. If we step back, the file I was just showing you a representation of is this acm.yaml file in the middle. And what that does is it references each of these system templates. And a system template, and I'm adjusting the colors on this. A friend of mine told me the fancy colors, someone who was part of this workshop maybe last week, said some of the fancy colors were a little bit hard to read. So this is black and white to be a little easier. But the idea here is that a system might be composed of some number of different types of services. For example, we just showed you the system templates, well, the system templates each might be composed of some number of types of services. Each one of those types of services might have some number of instances. So there might be anywhere from 1 to, however many types of services. And each one of those types might have anywhere from 1 to some number of instances of that type. And they might or might not share some basic stuff that they all use, which might be things like networking, or there might be things like image definitions that get used to create compute instances or other types of things. And what you see on the left is a graphical representation of a system template. And then on the right, you see a graphical representation of a different system template. And the one on the right does not have any foundation just because for its situation, it doesn't need them. So you're left with the fact that in this other one, you've got 3 different types of services. You could have 1 or 5 or 3 or however many. And this is as complicated as the domain-specific language has to be. And from a business standpoint and from a high-level architecture standpoint, it's just, it can seem a lot easier to group things at this level. And that's as hard really as the domain-specific language is. It's designed to be very simple so that it can make other things that are more complex look a lot simpler from the business level. I could take you through the command line interface, but before going too far into this, does anyone have any questions or comments about the domain-specific language? Mainly, the thing to get from this is not just you're organizing things into logical groupings to simplify, but when you're organizing them, if you look at one of these templates at some point, basically what's in the template is a lot of variable mappings. And so it's basically taking variables and pushing them, taking them from some configuration file you've got and pushing them out into all your third-party templates you've already got. And that's essentially as hard as it is. And if you got rid of all those variable mappings, you basically have a list of service types and service instances with a foundation and maybe some images in the foundation. And it would, if you got rid of all the variable mappings in one of these templates, it would be very few lines of code. So they're very, very simple. And then you've got the command line interface. And here we're just pointing out 5 things. And you can see, starting with number 1 on the top, we've got a command that's appliance on, ACM appliance on. And what that does is it creates an entire appliance. And then you've got a command ACM appliance off, and that'll destroy the entire appliance. And that's what the demos are doing right now. And then we can also work on pieces of it. So we can turn a foundation on, or we can turn a foundation off. And we can turn, if we go to 3 here, all of the services on in a system, or all of them off. And we can further go in and perform more surgery by turning all of the instances of a particular service type on in a particular system, or we can turn them all off. And then the 5th thing is we can operate on an individual instance of a service by turning it on or by turning it off. And if you think about it, these are simple 1-line commands. And level 1 up here is just literally these 3 words, ACM appliance on or ACM appliance off. And these other ones, they add some flags to them. So you'll say the 3 words, and then you'll say, obviously, which system it is. So that's 1 flag. You know, for the services, you're basically adding that same 1 flag to say which system it is. For this one, you got to say not just which system it is, but also which type of service it is. And for this one, you say not just which system and which type of service, but which instance. You do all that in 1 line of code, and it becomes very, very simple to take pipelines that used to be hundreds of lines of code and reduce them to very small numbers of lines of code, and they're a lot easier to maintain. And that's the collection of slides that I intended to invoke some engagement with. And then there are questions, and the intention was to answer your questions by going through the website and the demos, which are almost all done here. One of them, the ARM template demo, is still running. Do people have comments or questions about what I've shown you so far? I can take you through this. You can see that this program we're talking about is basically available. You go to the website, and it takes about, oh, I lowered this here. It takes about 40 milliseconds to download, so it's super fast. If I click on it, clicking on it is actually good. But yeah, there you go. Once it starts to download, it just shoots down real fast. And then the other thing I was going to point out here is we have a meeting every Wednesday at noon Pacific, so 3 Eastern, of people who want to contribute to this if they're using it. And there's also technical support that's available for architectural engagements that are available. If someone wants us to come in for a day or for a week or for 6 weeks or possibly for longer. And I'm just going to show you this here. If someone wants to do this, we have this idea, and I could shrink this, maybe make it easier to see on a page. I'm assuming not everybody has governance in their company. Do any of you have architectural governance systems that you work with in your company?
Yeah. I do. Yeah, it's a lot of rigor to it. Yeah.
What is this stuff we've been going through cause you to think about in terms of how your project management group and your architecture group and the governance organization, how they deal with these concepts?
It's different. Ours is driven modeling after the PMO governance, and basically check this, check that, basically, and have diagrams to show everything. But they're all different, all the diagrams. But I mean, we use a lot of SharePoint and a lot of Lean IX and other stuff like that for our architecture governance. But it's transforming. They've been updating their governance in the past year, so yeah, financial institutions, toll gates, and architecture governance, InfoSec governance are there's a lot of rigor to it. Yeah, this is different than what we see, though. Yeah.
Okay. The idea here is to work with whatever governance system you've got, and not to impose one, because people have great stuff already. But like you're saying, governance changes over time, and in a lot of companies, it starts with a business case, and from the starting point of a business case, you move into a proof of concept, and you get the proof of concept up and running in the company. And once the proof of concept is running and it's passed all of its tests, then it can move from a lower environment into implementation here, the next step. And once it's been implemented in a particular place in the company, the idea here is that it's software defined. And because it's software defined, we can move from implementation to the next phase, which is migration. And migration might be, for example, if we implemented this system to orchestrate a database implementation or a storage implementation for a particular group, we then would be able to migrate that software definition from that particular group to the other groups in the company. So if we had 10 implementations that are redundant originally, we might do a business case and a proof of concept that we then implement into one of those implementations to replace the old implementation with this, which might be the same templates, but it's orchestrated through this. And then we might migrate from that one group to the other 9 groups in the migration process. And as that's done, then the evolution process involves making changes to one template that's reused across the enterprise. And the idea here, I jumped at 2 because that's where people often are starting with their governance process that has all these different groups in it, like a finance group and a project management organization, some business users and architecture. But if we want to implement this and integrate it into this, we've got step one on the left, which is engaging people. We've got all these articles on the website, and there are all these slides that are on the website. This is a slide from in a different presentation. And then we've got all these demos, the other number one over the left, which is just running the demos in the company. And the idea is at the architecture and business level, you can engage people with all of this knowledge that's available through this website. And then at the engineering level, you can run all of these demos and get them running in the company. And let me get the size back so I can move you around. If we go back one, from a business standpoint, we've got this other article quantifying the financial benefits. And this takes, the reason I showed you that one first is that oftentimes a governance process will have a business case step. And we'll start with what the components of a business case are. For a business case, you look at the current cost structure and the current financial benefits. For example, you might look at just simply what it costs to operate a system, what it costs to do the engineering maintenance and the ongoing engineering development for all of the redundant implementations of it. But you might also look at some of the things like the benefit to the organization if customers are able to sign up for multiple accounts more easily to make the company more profitable. That might be part of it also. But here this points out to several different levels of a business case for this. For example, reduced infrastructure development costs if you're doing one definition, reduced software development costs if you're able to spin up environments much more easily, so people can prove things out and test things in real environments more easily. You can have reduced patching and maintenance costs due to standardization across the enterprise. You can have reduced downtime of systems if systems become a lot more reliable because you're able to focus your engineering efforts on these reusable templates that become stronger and stronger and more reliable. Possibly reduce cloud provider bills, and then other financial metrics you come up with. And here this just goes through a process like we were talking about of, let's say there are 5 implementations of something and you want to bring it down to 1 implementation or 2. Well, if you had 2 of them, for example, you might come to 40% of the current cost level. And you're basically able to go through and break this down to see how you might come up with a 20% savings or a 10% savings. And the savings isn't necessarily something you want to do. It's what I'm trying to say, it's a better way of looking at savings, I think, is to reinvest in more use cases, because we need more IT people than we have usually. So the idea is not to have fewer IT people. The idea is to get more work out of the ones we have with the same number of hours. And this just points out a question, what does it cost in the company to have this redundancy? If we can increase productivity by 10% for the whole IT organization, what's that worth? If there are 500 people in the IT organization, a 10% improvement in productivity is 50 new IT professionals. That's a lot of money. If we've got 5,000 people in an IT organization, that's 10% is 500 new virtual IT professionals that get produced, and that's pretty substantial. And just going to show you here, all the demos are done. I can show you inside here what these are, but do people have any questions or comments? This feels a little interactive while we're going through a little bit of what happened in the successful demos. Click on this, and every one of these pipeline tools is going to be different. But here you basically see there was a job, and in the job, there are these different steps. It provisioned the Windows server, downloaded and extracted, the Agile Cloud Manager. It then runs this setup on command which pulls all the repositories from different places that are going to be operated upon. And then it runs the appliance on command, and that creates all the infrastructure. And then it runs the appliance off command, and then it runs the setup off command. So it basically spun up an appliance and tore it down. And if we go into this, it's going to show all this stuff that it organized, not to get into any great detail, but there's something called a change taxonomy in it. What it does is, for the appliance, it creates a workflow, and then it gives you the status of the work. It lists what all the steps of the workflow are going to be, and then it gives you the status of the workflow at each step along the way. And it organizes the things you might normally consider to be logs in between these workflow steps. And the workflow steps give you the real status, and it comes in a machine readable form, and then it comes in a form that's either machine readable or human readable, like this, which is the same information that just goes through the change indexes one after another. That could be one, or there could be 50, or 12 or 50 or however many. And sometimes there are latency issues. But here in the bottom, there's a human readable form. At every step in the workflow, it goes through and says, here's the current status of everything that's going to be changed. And basically, it looks like what happened here is the overall status change from not started to in process. And after it's gone through, you have here a TF backend system. It's got what's in there, an admin system. There's an agent system. And then underneath, it gives you what's the summary of this? Well, the only thing that happened is the overall status change from started to in process. And it's got this kind of meta information. And at various points in between these workflow updates, it gives the things that engineers usually see in logs, which are much more detailed, technical things. And that's that. And I was going to show you one other thing here. Set up on, maybe I was going to show it over here, which is you guys, here's this. I took you through this getting started, and getting started on a dev box is a slightly different process, not to get into, but we can take you through. It creates all your configuration, but I was going to show you what I showed Gabrielle and Cora earlier, which is here. We're running these commands: setup on, appliance off, and then setup off. If we want to see what's inside these things, all the code for this is sitting on web. Do this, and you can see that this command has this repository has a couple of simple files in it plus the license. One is your appliance file, which in this case is only 3 appliances, 3 lines of code, 3 systems and 3 lines of code. And then it's got the locations of the things it goes out and grabs. And in this case, it's building from Azure. So we've got these Azure building blocks that are all organized in one place. And from a governance standpoint, if you're able to put everything in one place in a company, it's just so much easier to keep track of it and make sure it's all being done the right way. And then each group subscribes to some subset of it. So each group's not getting everything that's available in the company, but they're getting something from a repository that subscribes to the everything repository. And I was going to show you is this, your system templates.
So in this way, you also define what is the software building of material for all of the things, the versioning, like everything. Correct, from whatever is defined in and stamped with the stamp of approval of the architect that wrote the template.
Yeah. So you can have, of course, obviously branches have, repositories have branches. So you can have versions of this that go through the branches, so that what's available is just, the final version that's released at any given point in time. And I've noticed oftentimes if things are done many different ways in different parts of the company. If you're able to organize starting from a particular location, you really solve that problem. People can reach in and get the next version of this easily enough. And this just points out all of your system templates are in one place. So.
And you have example over here for Terraform, for like different tools, how to integrate with those tools. I see the one you were mentioning before was mentioning Terraform, but Azure.
So if we wanted to see this particular way of doing it, has it organized by cloud provider. So there's an AWS building blocks and there's a Azure building blocks. But the way this is set up is, there's the Terraform and the ARM templates, the Packer. They could be anywhere. They just happen to be organized this way. The location is defined by what's in that setup file I was showing you. But here we've got, you mentioned Terraform. For each of these modules, there's a call to it. And, the templates for each one of these things can be rather simple. A subnet that has, this is basically sending a bunch of variables and it's referring to, it's pulling variables in, it's referring to them, and then it's sending this to this module of the same name because we're in the call to the module. And then you basically step back and one more, here we go. It's basically referring to all this code. So you're getting all this Terraform code that has, all the things that work, all the things that are being called upon. Is setting up your subnet and your security group and all of these different things.
Okay, and a lot of work, really interesting.
Well, the idea is to make it easier for people to work with the stuff they've already got. So, yeah, it's a lot's going into this, but the idea is to make it a lot simpler and to get to the point where all you have to do is point and click. Because let's go to actions here. We did this, and all we did at the beginning was point and click, and we started 8 different things running, and it spun up 8 different appliances, and it tore 8 different appliances down without us having to think about it. So that's the scope. If somebody has any questions afterwards, that they're not bringing up now, they can reach out. There's the company page on LinkedIn. People can reach out by looking at my name, and then also the company name on LinkedIn, and you'll find me. And then the website also has a contact form in it.
I have a question more on the experience of putting this in place. Part of my mind is thinking about getting I guess buy-in from what's the process of getting enough buy-in and changing people's minds? Do you have to tend to go through and do sort of like a campaign and get people on board, because this touches a lot of different teams, right? That's one part of my mind. And then the other part is part 2 of the question, I guess, is how long does something like this normally take a company, and how far do you see companies taking this?
Yeah, that's an excellent set of questions. Let me write down how long, because that follows up your buy-in question. I would structure that a dialogue with people when they ask a person that with this slide that for some reason doesn't want to get all the way in there. I can shrink it, but I'll shrink the text when I do that. There we go, here like this. There we go. This gets a little bit more readable, but I'll make it a little bit bigger than this. For the buy-in process, the idea is let's get something working right away. And you want to ask people what hurts, but it's helpful when you've got something working right away. And the process of setting up those demos requires going through the link I was showing you, the Getting Started for Engineers page, I think it's set up now so that maybe in an hour or so, someone might be able to get the values that they need off of you know, the AWS website or off of the Azure portal. And once they're getting those values set up and they're in the right files, then running those demos you saw takes about half an hour. So certainly within a day, possibly within a few hours, an engineer might be able to get all of these demos up and running. So you start with something tangible that actually works and sharing the concepts. And I was talking about 2, the governance process, but really I think the answer to your question is in 3 here, which is asking people what hurts. What's the part of the company that hurts the most? In the past year, which systems in the company have broken to the point that the enterprise has had tangible losses? You know, did a website go down and have a particular service down for a day or for a week over the course of the last year, and that had implications for the business? How do you address that? What really broke and what's really going to fix the problem that broke? And that's what step 3 here is. You know, you're looking at what's going to be the most painful, what's going to be the highest return, what's going to enable the solution, and what's going to be the thing that you can fix the easiest. And then in terms of how fast, well, you got to go from something that works to something that's implemented. And oftentimes, if an organization's healthy and everything's running properly, a POC might be able to get put up in 6 weeks. And then the question is scheduling. I'm sorry, my office is at a busy street here, and sometimes big cars go by, like if you heard that. But you have this situation where once the POC has been properly you know, validated, then you just go through the implementation schedule at some point in time. And then you're getting buy-in, and you're right, it's a lot of people and a lot of listening, and you know, you take it one step at a time. But the demos can be run on day 1, and proof of concept might be put up in 6 weeks, and then depending on the company, and you know, from that point you're building buy-in in each step based on these questions about what hurts the most and what can we fix, and then what's the business case, how much money are we going to save if we have one implementation that's parameterized instead of however many we've got now.
You tend to see patterns about where people normally start, like where people normally have greatest pains at particular types of systems or problems. Do you see any patterns there?
Yeah, we were having this conversation, I think a few days ago. When you start talking about all this highfalutin stuff, you get put where things are broken. And the thing that really breaks this down in a company, I think, is at your storage and your database level. And once that stuff becomes really, really well automated, then from that, you start to move up to the higher levels of the systems. I don't know. What is your experience when you look at these types of questions? Where do you think you would apply this first?
That is a good question. I mean, you know, I think like it's, oh yeah, I'll just one quick thing, Gabby. I think the one sort of like one thing that I have seen is that sometimes the system, people tend not to start, you know, people identify the systems which are like the revenue generators, and there is some incentive to eventually get to those, but you never want to risk your business, right? So the thing that your business is relying on the most usually is, maybe it's not the first thing. You need to prove it on something important that is impactful, but it's not your core business necessarily as a first go. So I've seen sort of that where, like, you know, there's a trial, there's an effort internally to do it once, and then but still protect that core business. So it's like the highest, it's maybe the second highest return, because you have to balance the risk. I don't know, Gabby, were you thinking of something?
No, it's on the same line. Like the assessment can identify the greatest pain, but not necessarily is the thing that you want to start with. And yeah.
But it does have to be, but I feel like companies still need to start with something that is impactful. Like it, not the thing that would risk the business, but something that is impactful, because you do need to make an impact. And that generally starts this sort of like snowball, right? Where like people see it and then they're more on board. But I've also seen a lot of like campaigns within companies whenever there is sort of a modernization effort or a streamlining effort. It's an internal sort of marketing campaign to go around to other parts of the organization and say, look, we did this. You should get on board. We can help you in this way. Or, you know, you have to kind of go to each group, and each group has generally their own autonomy in deciding whether or not to adopt. So it's like an internal sales campaign in a way.
Yeah.
Somebody has to own that, right? Like there's groups that want to do it for themselves. But if you want to do it at scale, then I guess that's where that buy-in comes in, right? Like you're really, at some point there has to be somebody interested in doing it at scale for the enterprise and representing that effort from an enterprise perspective. And I've also seen that generally things are, you know, there's like a top-down, like sort of this has been dictated from the top down. All groups must do this, versus an alternative philosophy, which is like, we want to show you a way that's so good that everybody's going to want to do it. And the second one I feel like is the more modern companies operate according to the second model.
Yeah, I like that. It can be expensive sometimes, but I've seen, like you're talking about, a competition where every group or several of the engineering groups, they're charged with coming up with alternative approaches to doing things, and come up with the best practices and pull that up. One thing I was thinking about for when you're bringing up those points is that every one of us has their own viewpoints, but and assessments we make of things, the conclusions we draw. The conclusion I draw most frequently is that there's not often enough a culture of automation in companies. And so you end up with this situation where you get these very, very expensive vendor products that come in. And in my mind, 90+% of these very, very expensive vendor products are automation that companies could build themselves, but they don't. And the solution, oftentimes, when there's this huge fiasco in a company and a system breaks down on a mission critical enterprise and everybody's pointing fingers and blaming each other, the solution, I think that's the easiest and best and cheapest way, is to have an ongoing process of automation where you're taking the best of the best throughout the company, and you're centralizing, and then you're migrating, and you're evolving in a healthy organization where everybody's giving healthy feedback. And these are agile projects. That's why this is thought of, in my mind at least, as the Agile Cloud Manager. The idea is this is designed to be set up under agile project management with all these customer groups in the company that are bringing requirements and changing all the time. And instead, I think when the big fiasco happens, the first thing that companies do is they go reach out to the most expensive possible vendor and buy this product that they then go implement 10 different places in their company and spend way more money than they need to, when they could just automate what they have a lot better. That's my viewpoint about that.
Mm-hmm. I like that, you know, once you streamline these things, as you say, it puts you in a position to, like, if you do want to iterate and improve something and maybe even change it fundamentally, at least you've organized it enough that you're in a position to really think about that in a clean way. Yeah,
if the root cause of the problem is a lack of automation under agile management, where people are listening to who the customers are and they're coming up with evolving solutions, you're going to still have that problem when you buy this expensive vendor product. And it may make a lot of sense to buy that expensive vendor product, but it's going to be an awful lot less expensive, and it's going to make an awful lot more sense, I think, if you're taking an approach of coming up with best practices and parameterizing things.
one thing that I found really also interesting, I mean, many things, but I was also thinking about, you are pointing out how you can immediately run the demo and see the value. And then you were mentioning like 6 weeks, if I'm not wrong, in terms of setting up a proof of concept in the organization. So what would this 6 week represent? Like, are you helping the organization also writing, like collecting the templates, extracting what is important for the template? It's like it's an average of what you have seen in practice happening. Like, how do you propose this time? That seems pretty short, and of course you're going to bring some value after that. So I'm interested in understanding what is the process and the outcome from the proof of concept itself.
Yeah, different types of people are involved in this. So your business case, you're working with finance people, you're working with domain experts who are business people, you're working with engineering people to figure out what the process is and how that's going to be made less redundant and more efficient. But once you've done the business case and you move into the proof of concept phase, the idea there is you've got architecture that happens with a solution design document and with a low-level design document. And that's going to start with your use cases and your tests that are defined for the use cases and an architectural diagram that shows how all the pieces fit together at a high level. And that needs to go through some type of governance process and get approved. And when that's approved, then you might have a 6-week build out process. And in that time frame, your low-level design is going to be clarified. From an engineering standpoint, you've brought up some good points about you're looking at all the different variations of templates that currently exist, and you're comparing them and coming up with what you're going to start with as the best practice. But from an engineering standpoint, you can also look at it as a minimum viable product, and that's going to go into your agile project management and evolve over time. And from that standpoint, if you start over on step 1 on the left, where you're running these demos that you can download, and there might be 30 lines of configuration that go in, and there's a program in there that creates 27 of them through running just a simple program. So, or maybe you come up with, it creates 17, so maybe you need to come up with 12 or 13 different pieces of configuration. So you come up with that over the course of an hour or two, and certainly within half a day or at most a day, you get the demo running. Then I was showing you where the setup goes and grabs onto different repository sitting places. You just replace our examples with your own. So the process of getting your basic thing up and running in a small company can be really fast, because they just take the templates they've already got and they take the demos and they replace the pointers to our examples with the pointers to the templates you've already got, and you get that up and running, in a small number of days. And that's that's the beginning of it. But in a big company, you can't move that fast. In a big company, you got to look at that and say, we're going to see, we've got all these redundant templates, and we're going to try to listen and all of that. And that's where you're iterating through those 6 weeks, building something out. And in some point of that, you might have 3 weeks where in your test process in your big company, you might just have the thing get bombarded with every possible element of your test suite again and again and again until it finally passes everything. And that's where you get your 6 weeks in the engineering cycle. And before then, there's some solution design process and some business case process that might take a little bit of time. But you don't, at the end of proof of concept, you don't have to have perfection. You just have to have something that works well enough to be at least as good at what you already have, but a lot more efficient to use, a lot more efficient to operate.
Yeah.
Cool. Do we have any questions from the people in the who are on, whether in chat or if you want to unmute?
I'm good. Very interesting. Thank you.
Well, thanks, Mike, for the feedback. Gabby, do you have anything else?
No, I'm quite impressed by all
Yeah.
this work, and thank you for sharing with us, Jim.
It's nice to meet you guys, and I enjoyed talking with you guys. So I'll stop screen sharing, and thank you for the opportunity to share this with you guys.
Yeah, thank you so much, Jim. We really